Hey guys, welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're going to talk about pooling in convolutional networks. And then when we're talking about pooling in convolutional neural networks, we're also going to cover padding and why we're adding padding and what padding is when we're actually doing pooling. Because in convolutional neural networks, it is often we often use pooling after a convolutional layer. So we'll have these layers here in our convolutional neural networks, and then the convolutional layers will be followed up by a pooling layer, or we can do some different kind of operations inside of that pooling layer depending on our application or the purpose of our neural network. But first of all, remember to join the Discord server. I'll link it down in the description here, so you can join the community where we talk about some different kind of stuff within neural networks, deep learning, computer vision, and also if you have some problems with some of your projects, you can go ask them in there and chat with other people, or if you just want some inspiration for your own projects and stuff like that. So make sure to join that Discord server and come chat with us. So let's jump into the first slide here, where we're going to have a short recap of the last video that we made, which was kind of an introduction to convolutional neural networks. So this is what we're going to focus on from now on in this tutorial here. Like previously, we mainly focused on artificial neural networks, where we talked about the different kind of layers and neurons, and also some different kind of parameters that we can tune on, and how we can actually fine tune a neural network and do transfer learning and stuff like that. But in the last video, we talked about convolution, what convolution is, how we apply convolution on the images that we pass through our neural network by applying some filters that we're convolving with the image. And then we can do some different kind of operations, and then we can actually train our neural networks to extract some different kind of features in the different layers that we have in our convolutional neural network. And then we talked about after we have this convolutional layer here, we actually often use this pooling layer followed up after the convolutional layer here. And this is what we're going to focus on in this video here, where we're going to talk about some different kind of methods that we can use for pooling, and then we can actually also add something called padding to our pooling layer, so we get some different kind of features which can be helpful and useful in some different kind of situations. And then again here, after convolutional neural network here, we can actually have a fully connected layer, or an artificial neural network, where we can actually pass the images here that we flatten from the feature extracting region here. And then we can actually do some classification here at the end, where we can get out if this is a cat, dog, car, or something like that, or we get a probability of some specific situation that we're in. And then we also talked about some of the applications of convolutional neural networks, like how Tesla and Waymo uses convolutional neural networks and deep learning in general to for example solve full self-driving vehicles. And then we're also talking about the trainable parameters that we have in convolutional neural networks, because convolutional neural networks is a lot more complex than just a normal artificial neural network, because we have more trainable parameters. We have a lot of different kind of filters and stuff like that we can tune on, and the neural network it tries to find the best parameters for those while training. So we went over that in the previous video, so make sure to check that out before you continue with this video here as well, if you're not familiar with convolutional neural networks and what they are. But let's jump into the first slide here in this video here, where we're going to talk about what pooling is in convolutional layers, and also why we use it and why it can be useful, and also just how we can do it. So pooling is actually when we're actually going to apply some filter or some operations on top of our image. So often we will extract some features in our convolutional layer, and then we follow it up by a pooling layer. And the idea behind the pooling layer is here that we're actually looking at a region here in our image. So in this case here, we specify a region which is 3x3. So we'll look at this region here with the 9 pixels, or the 9 elements here in this array, and this could represent an image, for example. And we can also do this on a lot of other different kind of just matrices and stuff like that. So we're looking at this 3x3 array here, or this region here in the image. And then we can actually apply some different kind of methods or pooling methods on this region here that we're looking at. So we have these different types of pooling here. So we both have max pooling, we have average pooling, and then we have some global pooling. But in the case we're looking at a 3x3 area here in our image, or in our matrix, then we're actually then we can actually apply here max pooling or average pooling on this local area. So the idea behind max pooling is that we look at all the elements here in this area, and then we just pick the element with the highest value. So in this case here, if we apply max pooling in this area here, or this region here, the resulting value here would actually be 5. And then we just slide this kernel, or a kind of filter through our whole image here, and then we just move it pixel by pixel, or element by element, and then we just take the max value from that area, going through the whole image, or the whole matrix over here. But we can also apply something called average pooling, where we just sum all the values here, and then we take the average of all the values here. So we have some different kind of advantages and disadvantages for both of them, but we often use like max pooling after we have this convolutional layer, because then we only extract the most important features and the most important like pixels in that area that we're looking at. But we can also like use average pooling, which will just like smoothen out like the information or like the things we want to extract in our image. So let's say we have like a digit image, like for example in the MNIST data set, where we have like the handwritten digits. So if we just want to look like, for example, at a 1 here, like the digit 1, then we can actually like just use max pooling, because then we can like sort of like downscale our image, and then we only want like the most important information, which is just like a straight line down with high values in our image. So we can actually like just use max pooling and get the maximum values, and then we'll end up with like a really low scaled, or like an image with a low resolution and like a really low scale, so we can actually like only extract the most important information, and then we don't need to like store a lot of different kind of values and stuff like that, which has some very nice advantages when we are operating with convolutional neural networks when they get into more like complex applications and projects. But we can also use something called a global pooling, which is kind of the same. We can both use like average pooling or max pooling in global pooling as well. But in global pooling, we're actually like looking at the whole image here. So we take the whole image and then we just apply like max global pooling, for example, and we'll just take the highest value in the whole image here, or in like in the array, or like in the matrix that we're looking at. So we can be used, for example, instead of having the fully connected layer at the end where we just have like an output nearing, then we can actually just like apply global pooling to the image at the end layer, and then we just get a 1 value out if we want to get that from our application or project. So the most used type of pooling and why it's used and like how it affects the convolutional neural networks is probably like max pooling. So we often, as I already said, we use a convolutional layer, and then it is followed up by max pooling layers, where we just look at a region and then we go through the whole image element by element, and then we just take the max element from the area that we're looking at. So this is very often used because we only want to extract the most important information when we're going layer by layer in our convolutional neural network. But if you want it in your application and you don't only want to like extract the most important information, and you still want to keep like for example some of the background or like some of the pixels around the most important things, then you can actually like use average pooling instead of max pooling. But it really depends on your application and your project that you're doing. So now we're going to see an example of like how we can use max pooling on an image, for example. So we have this image here to the left, where we have like this matrix here where we represent it in pixels here, or like values for each of the pixels. And then when we want to apply max pooling, which is a 3x3 in this case here, so we look at this 3x3 area or region here on the image, and then we just take the max value from this region here, which is in this case 5 here, and then we apply it to the first element up here, because this is like the first region that we're looking at in the image from top left corner here. And then we just go element by element and do the exact same thing here, where we're looking at this, at the region and finding the max value. So we can see when we're applying max pooling on our image here, we actually like downscale our image. So beforehand we had this 5x5 image here, and then when we apply max pooling, this 3x3 here, then we actually like downscale our image here so we only have like a 3x3 image. So we actually like downscale our image so we don't have that much complexity, and then we extract the most important features from our image by only taking the max values, and then we downscale it to like compress our image and only get the most important information. But if we, for example, like extract it too many times, or like apply max pooling too many times, then our dimensions or like the scale or like our resolution of the image here can actually like be too low to actually like be able to extract more useful information. Then we can apply something called padding to our max pooling layer, or like max pooling when we're doing that on our image. But I'll talk about that in the next slide here, and how we can actually like still keep the dimension of our image even though we are applying this max pooling here with varying like area that we're looking at. So if we just continue doing the same thing down here with the max pooling here, then we can see that when we actually like striding, and we can actually like specify like how many strides we want to take for each like time we iterate through our image here. So in case we just stride 1 here, we will actually like just stride the image or like the filter here that we're applying by 1. So we just take this region here instead, and then we look at the max value inside of this region here, and then we extract that and put it at the next element up here, and then it will be a 6. And then at the next iteration we take this area here, take the max value, and then when we're done that, we slide 1 down here, and then we start from the start again. and then we take this area here, take the max value, and then we just keep doing that until we have been over like the whole image, and we have done like applied the whole like max pooling layer from our image, and then we have actually like downscale our image to only 3x3 with like the most significant values or the most important information in our image. So when we're doing max pooling, we actually like can apply something called padding, and what is meant with padding is that we just apply like zeros around our image here. So we just apply like a row here and a column of zeros here around our image. So this means that when we're actually like applying max pooling, we're actually like look at this area here instead of only this area down here where we just take the image, and then we actually like just look at the max values here. So actually like when we're using max pooling, it's good to use in padding because we're just taking the maximum values of these zeros here. They won't affect the image. But if we're using average pooling, for example, when we take the average of these values here, it will actually like affect the result when we're taking the average with this padding here, because we can see that we add like 5 zeros in this case here, and when we take the average of the whole region here, we'll actually like get a lower number compared to if we took the average of this region here instead. So we're actually like smoothing out our image more by taking the average pooling approach. But in this case here, we just take the max value here, and we can see that we have this image here where we have like a 5x5 image, and then we apply padding where we just like add the zeros here around our image. And then when we apply max pooling, we'll actually like keep the same dimensions as the original image. So we extract the most important features from our image, but we still keep the same dimension that we can then pass further in the neural network, and then we can extract more important features in the next upcoming layers, and then we can actually like apply max pooling again. But at the start, we actually like often in the first couple of convolution layers in the neural network, we apply like max pooling without the padding here, because we only want to like, we kind of like want to downscale our image so we don't have that much complexity, and we only extract the most important features. But when we get down to a really low resolution, like we often like want to keep the dimensions, so we have like a really good dimension, and we extract more and more features going through the layers in our convolutional neural network. So now we're going to talk about like pooling and patterning Keras and how we can specify it, and then later here after that we're going into like Google Colab, and then we're going to see like how we can specify this here in an actual neural network in code. But first of all, here we have this max pooling class here. So we have the different kind of classes that I went over. Like we both have average pooling, max pooling, and global pooling, and we both have in like in 1D, 2D, and 3D. But in this case here, we're looking at images. So we have this 2D max pooling that we're going to apply. Then we can actually just extract it from this TensorFlow Keras layers module here, where we can then get the max pooling layer here. And then we need to specify the pool size here, which is like the kind of like the pool or like filter size that we want to apply. So in this case here, it is 2x2, but the examples we went over here in the slides is actually like 3x3. And then we can also specify the strides. So the strides here is like integers, so it's a tuple of 2 integers or none. And it's the stride values, which specifies how far the pooling windows move for each pooling step, or like for each iteration. And if it's none, it will just default to pool size. So in the case of the strides here, we can actually like specify how many strides per iteration that it needs to take. So the examples we went over here in the slides, we actually like took strides of only like the size of 1. So we just went element by element, but we can actually like specify it needs to like skip a row or a column when we're actually like striding through our max pooling layer. Or if we specify this a none here, which is the default one, it will just make the same strides as the pool size here. So in the case here, we just specify none, and we have a pool size of 2x2 here. We will actually like make 2 strides in our max pooling layer, and that will actually like give half the dimensions of the image when we're using strides equal to 2 in this case here. And if we were using strides equal to 1 and we were adding padding to our max pooling layer, then we'll actually like keep the dimensions, which we're going to see in code as well. And then we can specify here if we want to use padding or we don't want to use padding in our max pooling layer. So we're now jumping to the Google Colab here, and I'm going to show you how we can actually like do this max pooling and pattern that I just showed you in the slides, and how we can actually like apply it on our sequential model and convolutional neural network here in Keras. So first of all, here we're just going to import TensorFlow with Keras and the different kind of like activation, the flattened layer, convolutional layer, and the max pooling layer that we're going to apply here in this video here. So I'm just going to run this block of code here, and it will import the different kind of stuff that we need. And if you want to use average pooling, for example, or global max pooling or stuff like that, you need to specify it up here in the import here. So in this case, we're just importing the max pooling 2-dimensional layer here. Then we can go down here to a sequential model here and see like what's going on. So first of all, we have these convolutional layers here in a sequential model, and each of the convolutional layers here are followed up by a max pooling layer. And then inside the max pooling layer here, as we saw it from the Keras documentation, we need to specify the pool size and like the region that we're going to look at in our image. And then we're going to specify the strides here that we're taking for each iteration that we're going through our image that we're passing through the neural network. And then at the end here, we specify that we want to use padding in this max pooling layer here. And if we don't want to have padding, we just specify it as valid instead of the same here. So we do this here for each of the convolutional layers that we have. So we apply max pooling of the convolutional layer, and we just have like the same parameters here. So we have the strides equal to 1, and like the padding, which is just the same here. And we also add padding to our actual like convolutional layer. So if we run this model here, it will just like create this sequential model here with convolutional and max pooling layers. And then at the end here, we flatten the output, and then we pass it to the like the dense or like the fully connected layer here at the end, so we can do some classification problem. But if we take the summary here of the model, so we can see like what's actually going on, then we can see we start with this 224 by 224 image, and then we have the number of filters here at the end. But we can see that we actually like keep the dimensions of our image when we're passing it through our whole neural network here. And this is because we're using this padding equal to the same here. And then we also specify the strides here, so we're going like 1 by 1 for each iteration. So this will keep the dimensions of our image when we pass it through our neural network here, which consists of different kind of convolutional layers and also different kind of max pooling layers. But if we actually want to reduce our dimension of the images, and we actually like often want to do that in the start of our convolutional neural network, then we can actually like just specify here if that we don't want to, like for example, we don't want to have padding, so we just specify this valid keyword here. And then we can also like specify, for example, we want to take 2 strides instead of taking only 1 stride when we are going to apply this max pooling like pool here that we stride over our image that we get from this convolutional layer here. But in this case here, if we're going to like apply this strides equal to 2 here, it is the same as the non keyword here. Because if we specify none here, it will just be like this default parameter, and it will just take the same number of strides as we're specified here in the pool size. So in this case here, we're going to try to run this sequential model here and create a new sequential model where in our max pooling layer here, the first max pooling layer here, we're going to take 2 strides instead of only 1 stride, and then we're not going to apply padding in this case here, which will reduce the dimensions of the image here. So if we go down here and run the new model here and take a new summary of the new model that we've created, where we're now taking like the number of strides here is 2 in the first max pooling layer, and we're not using padding in this case here, so we're actually like halving the dimension. So instead of we have this 224 by 224 image, we will only have 112 by 112 image in the dimensions. And then we just pass this through here in the rest of the layers in our neural network, because we're using strides equal to 1, and we're adding padding for the other different kind of max pooling layers here that were specified. But if we want to reduce the dimensions of the images even more, then we can actually like just specify the strides equal to some other number in the next max pooling layer. Or if we don't want to add padding, we just set it up here, and then it will reduce the dimensions further if we still don't only have the most important information that we want to extract from the images when we pass it through our neural network here. So this is how we can actually like use max pooling and padding in our sequential model here in Keras, and it can be used for a lot of different kind of things, and it's actually like good for tuning our neural network and reducing some of the complexity in our neural network, because often we don't want to pass our neural network, like our image, with this like fully dimensions here, which is 224 by 224. We actually like want to reduce the dimensions and the complexity of our image and only extract the most important information, so our convolutional neural network can learn the most important features in our image and then do predictions on that, and then also reducing like the training speed and the prediction speed, and just in general the complexity of our neural network. So this is what we can do with max pooling and padding. So this is why it's so important to know like how it affects the neural network, how we can specify it, why we want to use max pooling, when we want to use average pooling, and when we want to use like padding or no padding. So that's pretty much it for this video here, guys. We've been over like the different kind of stuff in convolutional neural networks with max pooling, global pooling, average pooling, and a lot of different kind of stuff, which is really useful when we're creating neural networks. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification here under the video, and also like this video here if you like the content and you want more in the future, because it just really helps me and the YouTube channel out in a massive way. And I'm currently also doing a computer vision tutorial in OpenCV in both like C++ and Python, and then later on we're going to combine it with deep learning here, so we can see like how computer vision and deep learning works together and go hand in hand. So if you're interested in that tutorial, I'll link to it up here, or else I'll just see you in the next video, guys. Bye for now.